In addition to the printed reports and forecasts disseminated by the National Weather Service, there are also various graphic weather products available for your use. Some of the more common graphic products are the surface analysis, weather depiction, radar summary, and low-level significant weather prognostic charts. These charts are designed to give you the general weather picture over a large geographic region in a glance. The surface analysis chart is a good source for this type of information. Here, surface pressure, frontal areas, and surface weather information have been combined into a single graphic display. Low and high pressure centers are readily identifiable by large L's and H's. Isobars, connecting points of equal pressure, are plotted around these centers. They are normally drawn at 4 millibar intervals and are labeled with the last 2 digits of the barometric pressure. Here, the isobar labeled 96 represents 996 millibars. Frontal boundaries are noted by solid lines. The direction and type of front can be determined by the symbols attached to the line. The front shown here has pointed barbs on one side, which identify it as a cold front. Since the barbs are on the east side of the line, the front is moving in an easterly direction. Weather briefers may color cold fronts blue to help you identify them. Half circles identify this as a warm front. Again, the direction of movement is shown by the placement of the symbols on the frontal line. In this case, it is moving to the north. For ease of identification, warm fronts may be colored red. A combination of half circles and barbs on opposite sides of the lines is used for a stationary front. The line is usually colored with alternating red and blue segments. A line depicting an occluded front has both symbols on the same side and is usually colored purple. In addition to pressure and frontal information, the surface analysis chart provides weather observations for a large number of reporting stations located throughout the country. For each location, a station model provides the reported weather conditions at the time the chart was produced. Let's take a closer look at each element of the model. The identifier is printed below and to the left of the symbol. LAF represents Lafayette, Indiana. The circle itself is shaded according to the amount of cloud cover that is present. Here, 3/4 of the circle is filled, indicating a broken cloud layer. A wind pointer indicates the true direction from which the wind is blowing. You can read the speed using the barbs at the end of the wind pointer. Each long barb represents 10 knots, while each short barb is 5 knots. In this example, the wind is out of the southeast at 15 knots. A pennant represents 50 knots of wind, while a circle around the station indicates a calm wind. When clouds are present, the level and type will be depicted in the station model. Low clouds are shown below the station model, with middle and high clouds printed above the symbol. You can find the decoding information for these symbols in various FAA publications and at flight service stations. To the left of the station circle is the temperature and dew point. If there is precipitation or weather obscuring the visibility, the appropriate symbol will be printed between the temperature and dew point figures. The symbol here represents intermittent snow. To the lower right of the station, the precipitation over the last 6 hours is recorded in hundredths of inches. The atmospheric pressure measured in tenths of millibars is shown in the top right corner. You must add the decimal and prefix the number with a 9 or 10, whichever brings the value closer to 1,000. The pressure at Lafayette is 1,018.7 millibars. Below this reading is the amount and tendency of any pressure change over the past 3 hours. At this station, the pressure has decreased 0.7 millibars. To ensure that you have the latest information, you should note the time of the observation. It is shown in a date time box in the lower left portion of the chart. Then, by comparing the current surface analysis chart with earlier ones, you can get an indication of how the weather systems are progressing. Another graphic display of the weather is the weather depiction chart, which can be very useful in determining general weather conditions and the locations of low clouds and visibility. This chart, like the surface analysis chart, uses a station model to present the reported weather at various locations. However, this model has been simplified, making it easier to read. Cloud coverage is shown in the same manner, but the pressure information, wind, temperature, cloud types, and station identifier are not plotted. Below the station circle is the height of the ceiling or lowest cloud layer in hundreds of feet. This station model is showing overcast skies at 10,000 feet AGL. If the visibility is 5 statute miles or less, it is printed to the left. Weather or obstructions to visibility may also be shown. The visibility at this station is 3 miles in fog. Although pressure and wind information is not provided on these charts, areas of significant weather are outlined to help with route planning. Shaded areas indicate IFR conditions and contain ceilings less than 1,000 feet and/or visibilities less than 3 miles. Areas of marginal VFR weather with ceilings between 1 and 3,000 feet and/or visibilities between 3 and 5 miles are shown in solid lines with no shading. Finally, weather depiction charts also give the position of fronts. This frontal information, when added to the areas of IFR and marginal VFR weather, will give you a very good picture of the general weather affecting your route. The radar summary chart is another graphic display that is frequently used by pilots and briefers. It is used to identify large areas of precipitation and hazardous weather that could affect your flight. Radar summary charts are developed by using reflected radar energy or echoes of the precipitation areas. The more severe the precipitation, the stronger the echo. Each radar observation station is then combined into one hourly map. The strength of the echo returns is shown by solid lines surrounding shaded areas. The outermost line indicates precipitation that is light to moderate. A second line within the echo depicts heavy to very heavy precipitation, while a third line shows where intense to extreme precipitation exists. A solid single line shows a line of echoes with the boxed SLD indicating that the echo coverage is 0.8 or greater along the line. The direction of movement of an individual cell is indicated by an arrow. The speed, 45 knots, is shown at the point of the arrow. The letters NE indicate areas with no echoes, while the letters TRW stand for thunderstorms and rain showers. Echo tops are encoded in 2 or 3 digits. You will need to add 2 zeros to determine the actual altitude. For example, the top of this cell is at 34,000 feet, and the top of this one is 19,000 feet. Because it is assumed that all precipitation displayed on the chart reaches the surface, the chart does not include a symbol to show the base of the echoes. An area which is under a severe weather watch will be marked with a dashed box and an alphanumeric identifier. In this case, WS0006 identifies this as a severe thunderstorm watch area. When an area is marked with a WT, it is identified as a tornado watch area. When using a radar summary chart, remember that radar only detects areas of liquid or solid precipitation. It will not, for instance, show areas of fog, and the actual cloud tops may be higher or lower than the figures shown on the chart. The charts we have seen so far in this program have all depicted observed weather conditions. Other charts, including the Low-Level Significant Weather Prognostic, or PROG chart, offer a forecast of future weather. PROG charts are divided into 4 panels. The top 2 contain 12 and 24-hour forecasts of IFR and marginal VFR conditions, turbulence, and freezing levels. These two panels forecast the weather from the surface through approximately 24,000 feet. The bottom two panels forecast the location of pressure and frontal systems, as well as the areas and types of precipitation on the surface itself. Areas of IFR conditions, where ceilings are expected to be less than 1,000 feet and/or visibilities less than 3 miles, are enclosed by solid lines. Scalloped lines enclose marginal VFR areas where ceilings are expected to be 1,000 to 3,000 feet and/or visibilities are forecast to be between 3 and 5 statute miles. Areas which are forecast to have moderate or greater turbulence are enclosed by dash lines and contain symbols indicating the intensity and altitude of the turbulence. In this case, moderate turbulence can be expected from the surface to 3,000 feet over this area of the United States. The position of the freezing level at specified altitudes is also shown on the chart. A zigzag line is used to identify the freezing level at the surface. Freezing levels above mean sea level are indicated by dashed lines drawn at 4,000-foot intervals. On the lower panels, fronts and pressure centers are presented in the same manner as they are on surface analysis charts. In this example, this high has a barometric pressure of 1,022 millibars. Solid lines are used to denote areas of precipitation. Symbols are inserted to denote the type of activity expected. For example, 2 dots indicate rain, while 2 star symbols represent snow. A mixture of precipitation is indicated by showing 2 pertinent symbols separated by a slash. These symbols represent rain showers and thunderstorms. A bold dash line is used to separate precipitation with contrasting characteristics within an outlined area. For example, this dashed line separates an area of snow from an area of rain. Continuous precipitation is a dominant and widespread event, and therefore is shaded. Intermittent precipitation is a periodic and patchy event and remains unshaded. Shading is also used to denote the amount of precipitation projected in a specified region. Areas with more than half coverage are shaded, and half or less coverage unshaded. The charts that have been presented in this program are but a few of the graphic weather products that are available for your use. As we have seen, charts of these types are very useful for obtaining a brief, general overlook of the existing and forecast weather along your intended route of flight and the surrounding areas.